So these ones aren't math problems, math heavy problems. They're more just explanations. And so we're going to have everybody answer together using Pear Deck. So if you logged out of Pear Deck, if you could get back in by going to joinpd.com and typing in that code, QOZRPM. And then you should be able to type, I believe, now. So the first question, number 5, was asked in drag racing. Is it possible for the car with the greatest speed crossing the finish line to lose the race? And explain yourself. So go ahead and you can start typing in the box. That's all right. Hopefully you're able to still hear what we're talking about. All right, so I'm going to start showing you responses. If you're not quite done, just keep typing. Your name's not attached to it, so I can see whose name is, but you can't. So yes, because the car takes a long time to get to that speed, so slow acceleration. The other cars can pass before it gets to its top speed. No, because it would get there before the other cars. Cars the greatest speed, completely possible for them to lose a race. This is due to the speed only being the finishing speed, not the entire race speed. He could be going 40 the entire race, then fired up to 120 at the finish, while the others keep a constant 90 throughout. All right, so that's a pretty good explanation there. So I'm going to kind of hit on this one. So instantaneous speed is different than what's called average speed. So one can maintain a high average speed the whole race, while one starts really slow and then gets really fast at the end. Okay, so you can speed up like it says 120 at the finish line, but still lose, even though the instantaneous speed at the finish line is faster. If it started slow, then it could end slow, or it could end fast. Start slow, end fast. This is like the tortoise and the hare. I'm sure you've heard that story before, right? So slow and steady. The turtle was going slower, right? But the rabbit had to speed up right at the end. But even though it was going faster at the end, it still lost to the tortoise because the tortoise was slow and steady the entire race. Okay, so it's something like that, right? So that is the correct answer. So it is possible, because if you're slowly accelerating, even though you're moving really, really fast at the end, if the other person started really fast and ended at that same kind of slower speed, but they could still finish before you. Are there any questions about that idea? All right. I will say, though, the average speed must be, if you're going to win, you have to have a faster average speed over the entire race. Even if your instantaneous speed at the end is slower, your average speed has to be faster over the entire race. All right, thank you. All right, next one. So number 10, can the velocity of an object be negative when its acceleration is positive? And what about vice versa? So that would be vice versa would mean velocity is positive when the acceleration is negative. All right, I'm going to start showing some of the responses. So yes, the velocity of an object can be negative while the acceleration is positive because it's slowing down or speeding up. Yes, it can happen when an object is already in motion, but then is affected by an opposing force. So even though we didn't talk about force, yes, that is true. That's what's causing these accelerations. So depending on how great the force is, it may take a while until it converts velocity's direction. Yeah, so like that one, I'm going to kind of show a picture of that one. So yes, it's like a car slows down, their velocity is positive, but acceleration is negative. For the other way around, it's trickier. But if it's like a car is driving to the left and the left is labeled as negative, it begins to brake, and the acceleration is positive, but the velocity is negative. Right, yes, that's a really good explanation as well. And I'll draw that picture in a minute here. The velocity of an object can be negative when the acceleration is positive, vice versa, due to the fact that acceleration velocity can be negative depending on which direction they're moving. Okay, both cases can be true because the acceleration indicates a change in velocity over time, meaning the velocity value can be positive while it is decreasing over time, negative acceleration, and vice versa. When the acceleration is positive, the velocity is negative. No, because if the acceleration keeps going up, that means there's some type of velocity. If it is decreasing, there would be some type of velocity being lost. All right, so let me, if you come back to the the Google Meet real quick. I'm going to draw out these two things that all right. Can you see that on Google Meet? So we're going to do number 10. So if we have a car, again, my beautiful drawings of cars here. So let's just say that to the right is going to be positive x direction, okay? So if the car has negative velocity, which direction would the car be going? To the left, because it has negative velocity. So it's actually going backwards, right? Negative velocity, backwards. But if it has positive acceleration, which direction is the acceleration? To the right, positive acceleration. So if the car is moving backwards, meaning negative velocity, but then it has positive acceleration, what is happening to the car? It's actually slowing down, okay? So if velocity and acceleration are opposite directions, that must mean that the car or the object is slowing down. So that's why I don't like the word decelerating, because here positive acceleration means decelerating or slowing down because the acceleration is the opposite direction of the velocity. So same thing if we look at the other case, vice versa. If the car is positive velocity, it's moving to the right, which means that's positive velocity. But if it has negative acceleration, the acceleration is to the left, which means the car is slowing down again. It's moving forward, but slowing down, okay? So the velocity tells you which direction the car is moving, but then the acceleration tells you whether it's speeding up or slowing down, okay? If velocity and acceleration have different signs, one positive, one negative, that must mean the car is slowing down. If they have the same sign, that just means they're speeding up, either speeding up to the left or to the right, negative or positive. Are there any questions about that idea? All right. Back to Pear Deck. 12, is it possible for an object to have a negative acceleration while increasing in speed? If so, provide an example. Okay, I'm not going to give you too much time because we're going to run out of time here soon. So here's some of the ideas. Yes, a car can be going backwards at an increasing speed. Speed doesn't have a direction. All right, very good. That's actually the correct answer there. So yes, if the car is moving backwards, it's a negative velocity. But if it's increasing speed backwards, meaning speeding up backwards, it just has a negative velocity and a negative acceleration. So it's going to speed up backwards. So that would be the correct answer there. Okay. So thank you for those of you who shared. Okay, move on to the next one. Number 13. This one has a lot of numbers and words in it, but I think once you see it, or once you kind of read through it, you hopefully understand here. So two cars emerge side by side from a tunnel at the same exact time, at the same exact place. Car A is traveling with a speed of 60 kilometers per hour, but has an acceleration of 40 kilometers per hour per minute. Car B has a speed of 40 kilometers per hour, but has an acceleration of 60 kilometers per hour per minute. Which car is passing the other as they come out of the tunnel? This is actually very similar to the drag race one. Okay, so explain your reasoning. So car B will pass the other because it speeds up faster. Even the car A is going faster at first. The car B will pass as it speeds up. B car will be passed. Car B would be passing car A because it has a greater acceleration. I believe that A would be passing car B due to the fact that car A kept a higher constant speed throughout the time in the tunnel, which means car A is already ahead of car B. Car A is going faster and is going more distance. Car A is passing car B. Car B would eventually pass. As it increases, car B will pass the other car as they come out of the tunnel. This is because car B, while starting a lower velocity, will increase its velocity at a greater rate than car A. Car A will pass car B because although the acceleration is low, it will be at a faster speed at the time of the come out of the tunnel. All right, so yes. So because car B because car B is slower, sorry, car A is going to be passing car B as they come out of the tunnel. Okay, right at the edge of the tunnel, car A is in the process of passing car B. That's because it's moving faster at that point. Car B will eventually speed up enough to pass car A, but at the very end of the tunnel, car A is moving faster, which means it must be passing car B at that point. In the future, car B will eventually catch up and pass it. But at that point, which car is passing the others that come out of the tunnel is car A. All right, last one here. I'm just going to talk about it. As a freely falling object speeds up, what is happening to its acceleration due to gravity? Does it increase, decrease, or stay the same? If you did not watch the videos, this is really important. The acceleration due to gravity always stays the same at 9.8 meters per second squared. So even though it's speeding up downwards, the acceleration is constant 9.8. Okay, so the acceleration stays the same the entire time. All right, we have to finish there.